Welcome to the SOFICS video tutorial. In this video, we look at system-level ESD protection for packaged ICs found in everyday electronic devices like smartphones, laptops, and IoT sensors. System-level ESD protection differs from component-level or on-chip ESD protection. On-chip ESD protection is aimed at preventing IC failure due to handling by machines or people during manufacturing and assembly processes. Once ICs become integrated into packaged chips and boards, the on-chip ESD protection structures are not so active anymore. The electronic devices are not completely safe from ESD though, as external ESD events can still cause IC failures. Unlike on-chip ESD protection elements, which are typically characterized with component-level tests like the human body, charged device, or machine model, system-level ESD performance is characterized according to the IEC 61000-4-2 test standard. The IEC 61000 standard is originally meant for full systems like smartphones, cars, and televisions. In recent years, it is increasingly applied to boards and packaged chips. At SOFICS, we develop the best on-chip ESD protection solutions, extending the standard libraries offered by foundries. We make it possible for you to choose any ESD requirement necessary for your chip. In the last 10 years, we have frequently received requests to provide on-chip ESD protection structures that can also pass the IEC 61000 test. These are basically on-chip transient voltage suppressing devices, TVS for short. There are no standard test conditions for IEC 61000 on a chip. As such, each of these requests requires a custom solution. When developing on-chip TVS, there are three main aspects which need to be considered. First, there is the fact that system-level ESD stress introduces a much higher ESD current. For example, 8 kV IEC 61000 has a much higher peak current than 8 kV component-level HBM stress. As such, the on-chip ESD devices must be scaled up in order to withstand these high currents. For example, in a worst case scenario where we need to protect for 8 kV IEC stress level, we need to scale up the ESD clamps to 16 amperes of TLP current, or equivalently 24 kV of HBM. Second, system level ESD has a very fast rising edge. It can rise from zero to peak in about 1 nanosecond. In this respect, it is similar to CDM stress, as it can cause IC failure if the ESD protection structures do not trigger fast enough. At SOFICS, we characterize ESD protection clamps with VFTLP measurements to ensure they can react to the fast transients and withstand voltage overshoots caused by system-level ESD stress. Third, system-level ESD stress is frequently applied on powered chips and may cause latch-up if the ESD clamp holding voltage is below the power supply voltage, or if the ESD clamp injects carriers into the substrate and triggers a parasitic device with low clamping voltage. SOFICS engineers have developed various ESD clamping concepts with high holding voltage to ensure latch-up immunity is guaranteed even during severe system-level ESD stress under powered conditions. So we move on to some examples of past projects where SOFICS needed to develop solutions for protection against IEC 61000-4-2 standard. We've worked on projects in 180 nanometer PCD. This was for an automotive application. In 130 nanometer CMOS for an HDMI switching interface requiring system level ESD protection, and on 40 and 28 nanometer CMOS for DisplayPort interfaces requiring protection for high-speed signals against system-level ESD stress. In summary, we note that even though the IEC 61000 standard was created for system-level ESD stress, it is frequently used for standalone ICs. The test approach for chips is neither defined nor standardized for this requirement. Consequently, it is important to have a discussion about the test conditions and acceptance criteria. Feel free to reach out to us to start a conversation about system-level ESD issues for your next chip. Thank you for following this video, and please stay tuned for the next one in the series.